Hi, this is Professor Muldrow, and we're going to do Chapter 2, Lab 4, where we are going to draw this figure. As you can see from the description on the left, the top and bottom lines of this figure are 16 equal signs with hashtag symbols on either side. All the lines in the middle begin with a straight up and down line on the left and the right, followed by a set of blanks, a diamond symbol, a set of dots, another diamond symbol, and another set of blanks. It is correct to assume that the number of blanks on the left side of each line is the same as the number of blanks on the right side of each line. So how do we draw this? We're going to set up three methods in addition to main, one called top half, another called bottom half, and another called line. Now we're going to use nested for loops to draw these lines that have the blanks and dots. So we have to figure out what the correct formula is to use in their for loop conditions. We have them on this slide. This is the formula for the spaces, and this is the formula for the dots. Now, let me show you exactly how we came up with those. Here in this Word document, I've come up with the same patterns. For example, line 1 has 6 spaces. Line 2 has 4 spaces. Notice the number of spaces on each line is decreasing by 2. So to figure out the formula, the first thing I do is I take -2, since we decrease by 2, and multiply it by the line number. In this case, that is 1. So -2 times 1 is -2. But I want to get a positive 6, so I must add 8 to get positive 6. Similarly, on line 2, I take -2 times the line number, which is 2. That gives me -4. But I want to have a positive 4. So again, I must add 8 to get the result I want. That means the formula for the spaces is -2 times the line number plus 8. Similarly, for the dots, on line 1 we have 0 dots, on line 2 we have 4 dots, line 3 we have 8. So the number of dots is increasing by 4 on each line. So here on the first one, I take 4, positive 4, times the line number, which is 1. 4 times 1 is positive 4, but I want a 0. So that means I must subtract 4 to get that 0. Similarly, here on the second line, I take positive 4, my increase, multiply it by the line number, which is 2. That gives me positive 8. But I want positive 4. That means I must subtract 4 to get the positive 4. And so the formula for the dots will be 4 times the line number minus 4. Here's the code for the top half, which I also have in Java. So as you can see, I have my outside loop. I'm using line as the loop counter, and it goes from 1 to 4. Now, I'm drawing I draw my up and down line. Here is one inside loop where I'm going to draw the blanks. Notice here is the loop condition. X begins at 1, and X is less than or equal to -2 times line plus 8. When that loop is finished, I then draw a diamond symbol. And then I move on to the next loop to draw the dots. Notice the condition for drawing the dots. Positive 4 times line minus 4. Then I draw another diamond symbol on this line. And here I have another for loop to draw blanks. But as I said earlier, the number of blanks on the left is the same as the number of blanks on the right. That means this loop, to draw the blanks on the left, is exactly the same as this loop to draw the blanks on the right. And then I have a straight up and down line to end that line. This is how we draw the top half. Now to draw the bottom half, you might think, oh my goodness, we need to rethink this whole thing again, but not really. For example, here's line number 1, where we have a bunch of blanks, no dots, and 2 diamond symbols. Doesn't that look the same as line 4 of the bottom half? Similarly, here is line 2 of the top half. That looks the same as line 3 of the bottom half. What I'm getting at is the bottom half is an exact mirror image of the top half. And so if you want to draw it, I claim all you have to do is change your outside loop to count down as opposed to counting up. Here I've changed the bottom half. The outside loop begins at 4. My condition is line is greater than or equal to 1. And I'm doing line minus minus. I'm decrementing as opposed to incrementing. I claim that alone will give me the mirror image I'm looking for. When I compile this and run it, lo and behold, that's exactly what I get. There's my output. So it works. Okay, now we're going to do something different with this image. We're going to scale it. The image we drew originally was a size 4 because there were 4 lines in the top of the image and 4 lines in the bottom half. The other image you see on this slide is of size 3 because you have 3 lines in the top half and 3 lines in the bottom half. Also, notice the number of equal signs in the very top line decreased. Here we have 16, which we use just a simple for loop to draw. But here, in the size 3, there's only 12. They decreased by 4. In order to be able to scale this, we are going to use a class constant. The way you define a class constant in Java is you use the keyword public, then static, and then this keyword final. That is what tells the compiler this is a constant instead of a variable. You must still give it a type, you must give it a name, and then it must be set to some value. Here you see 3 examples of that. I'll start with this one. Public static final int days in week equals 7, since there are 7 days in a week. Now it is not required that you make your constants all capital letters, as you see here. However, it's a very common practice among programmers to make constants all capital letters. That way, we don't mistake them for variables and try to change their value. Now, in order to get each size looking correctly, the first thing we have to do is change the outside for loop in the top half and bottom half. Like here in the top half, instead of saying I is less than or equal to 4, we say I is less than or equal to size. Here is the size constant defined right up here. Similarly, in the bottom half, which counts down, originally it counted down from 4. Now it's going to count down from whatever size is. However, this also means that we're going to have to make some changes to at least one of our loop condition formulas. Here's how we determine that. Once again, your size 4 drawing is on the left, your size 3 drawing is on the right. For size 4, the spaces go 6, 4, 2, 0, so the formula for the spaces on a size 4 is -2 times line plus 8. If it's a size 3, the number of spaces on the first line is 4, and then 2 on the second line, and then 0 on the third line. The formula for the spaces for a size 3 drawing is -2 times line plus 6. So as you can see, It's the number we add to negative 2 times line that changed. But 8 is 2 times 4, and 4 is the size. 6 is 2 times 3, and 3 is the size. So that means the formula needs to be changed to this, negative 2 times line plus 2 times size. Now, fortunately, the formula for the dots does not change. Here's the formula for a dots when it's a size 4 and for a size 3. It's the same formula. So the formula for the dots doesn't need to be changed at all. It's only the formula for the spaces. So when you put that in the code, you get this. Here is my constant. Here's where I'm changing the loop condition. And then for both loops that do blanks or blank spaces, here is my new loop condition, negative 2 times line plus 2 times size. I do the same thing here in the bottom half, only I have to initialize my outside loop to start at size instead of 4. And then, once again, here is the condition for the blanks. And there's one more thing. There is a method to draw the line. As you can see, we start with the hashtag. We have a loop to draw the equal signs. And we have a hashtag to end it. Before I added the size constant, for a size 4, there were 16 equal signs. So in that case, I could make my loop go from 1 to 16. But now that I'm scaling it, remember, size 4 had 16 equal signs. Size 3 had 12. So it's 4 times the size will be the new number of equal signs that are drawn. And when I compile this, and when I run it, there's my size 4. Now, if I come to the top and change the size to, say, 6, and compile it, there's a size 6. I could go even bigger. Size 10. And there you have a size 10. 10 lines on top and bottom. If you have any questions, please feel free to send me an email at kmuldrow@lbcc.edu.